class, today we're going to be talking about projectile motion. Projectile motion is a form of motion in which an object is thrown near the Earth's surface and moves along a curved path, in our case a quadratic. Here we have a sample problem of projectile motion. The problem reads, Carlos kicks a soccer ball at an angle of 40 degrees above the ground with a velocity of 11.3 meters per second. The question is, what is the maximum height the soccer ball will reach in the air? Note that the final velocity in the y direction is 0 meters per second at its maximum. And my partner Jose will demonstrate just how that can be solved.
Alright, so to solve this problem, we must first find the initial vertical velocity so that we can then find the maximum height that the ball reached. After we find those values, we will substitute that into a second equation, taking into consideration that the final velocity of y is 0 meters per second at its maximum height. Ready? Alright, so to find the initial vertical velocity, what we did was multiply the initial velocity by the sine of theta, which in this case was 40 degrees. Now we did these calculations beforehand, and it turns out to be 7.2635 meters per second. We will now use the initial vertical velocity and plug that into our second equation, which will help us solve the max height that the ball reached during its trajectory. So this is the final equation that we're going to be using. Now the equation reads, the final velocity of y squared is equal to the initial velocity of y squared minus 2 times the Earth's gravity multiplied by the distance in y, which is also the max height. Now we have to take into consideration that we said earlier that the final velocity of y was equivalent to 0 meters per second, and the constant g is the gravity on Earth, which is 9.81 meters per second. So now it's just a matter of simple algebra, and we're going to plug in all these numbers to find the maximum height that the ball reached. So after substituting all the values that we have from the given into our second equation and a little bit of manipulating using simple algebra, we arrived at our answer. And our answer is 2.689 meters, meaning that's the maximum height that the ball reached in its trajectory.
Okay, so after all the calculations, we got our answer and we have enough information to finish a graph. We can graph the angle, the maximum height, and the final height. And we will show you the graph and a short video of how this can be applied to real life. So we're at the park now, and we're going to show you just how the situation can be applied to real life. Here we have a cone 80 feet away, and the objective here is not to make a goal, but to measure the maximum height in the air and to measure the distance traveled when the ball hit the ground after being kicked. We made it!
Turn me up just a little bit in the headphone. Worldwide.